Hi, I'm Miguel Ángel Romo Aceves, and this is my area Eng.Sc.D. Study case and scope. So first, the study case was to model a suspension for an automotive vehicle. The scope was to model this suspension only for a quarter of the vehicle, having only 2 degrees of freedom. And for this, we have collaborative work. I think that the collaborative work was very well in my team because we all worked together when we had problems, and we also distributed the task among ourselves equally in a good way. I think that this way we work better and we communicate very effectively. We didn't have problems with that. But there are the pros and cons of working collaboratively. The pros, as I said, was that the work was easier and faster to do, and all the things that I just mentioned. But the cons were that is sometimes my teammates were busy or I was busy, so I didn't have time to do the task that I had to do. So these were when we got slow a little bit by this. And with a teacher, we worked very well as well. The only problem was the same. Sometimes he was busy and he didn't have enough time, but we only waited and he helped us later. About the research methodology, first, what we did was to question what are we looking for? And we were looking for a suspension of active suspension for a quarter of a vehicle. Then we did a research having all this. Then we did a hypothesis, and lastly, an experimentation. After the experimentation, we did a simulation. We got the results, and those will be the ones that I will show you later. So now I will explain you what's a passive and active suspension. Passive suspension is, well, first, a suspension is a system of a vehicle that a vehicle has that absorbs the force of the road. We can see this in this GIF, how both the active and passive absorbs the force. We can see how the active is smoother than the passive one, and that's the difference. And the difference is because, as we can see here, the active suspension has an actuator, that it's the DF here, that gives a force that makes the drive smoother. We can see that the diagram has sensors, a controller that controls the actuator. And here we can see how the other suspension, the passive one, only has a damper and a spring. The active one only additionally has the actuator. We can see how all of the things are connected, and the force is distributed in the 3 things or 2. Here it's the block diagram that exemplifies what I said. Here comes the signal, it goes to the controller, the plan, the signal conditioning, the sensor, and it goes to the block, to the sum point. And if it's right, it goes to the output. And that's how I did it. Now here we have the dynamic equations. These dynamic equations were taken from this. Based on the Newton's third law, we did these equations. Ms is the mass, the upper mass, the chassis, in all the vehicle, and mu it's the lower part of the vehicle, so it's only the wheel. So it's only the wheel. So based on these dynamic equations, we have now the modeling approaches. To model this quarter of a vehicle, we did the differential equations. Here are the 2. We solved them, by two ways. First, the Laplace transfer function, and we got these three equations. And after that, with a state space, that we got four x's, and four outputs. Now, I will show you how I put those in Simulink. We can see, first of all, I want to say that these are the data that I use. So this is the Simulink. In the upper part, the upper block, we can see how I simulated the differential equations. In the middle, are the transfer functions, these three. And lastly, we have the state space of the equations. All these three things say the same, have the same output and the same input. So they are all the same. There are only different ways of modeling the problem. Here, these blocks shows in a graphical way the outputs. The other thing to say is that here are the inputs. We have two inputs. First, the road bump that simulates a road bump, and this sign function simulates a rocky road, and that's all about the simulation. Here we have the results of the Simulink. On the left, we have the passive suspension. We can see that the passive suspension doesn't move a lot. Meanwhile, the active suspension moves a lot more. Here's the road bump test. And now we have the difference between the CU and CS. We can see that there's more difference in the passive suspension, and this is because the suspension doesn't move a lot. That's why there's more difference. Here we have the difference in acceleration, and here we have the difference in the road disturbances. As we can see, the active suspension moves more than the passive suspension, as we see in the road bump, and we have the same results here in the differences and the acceleration. So having this, we can see the difference. The active suspension moves more with the road, so it would feel smoother. But how much is difficult to say, because it look that it moves a lot, but in practice it may move very little, because it only move like 3 centimeters more than the passive suspension. So knowing if it will be a lot smoother, it's very difficult. So I think that it's not worth it if the price of the active suspension is very expensive. Now I'll review a literature of the solution of this suspension. We found this active twin accumulator suspension. This has a similar system that the normal suspension, but the spring is connected to a damper and another spring, as we can see here. And there's also the passive suspension and the active suspension. The active is the same, only that it has an actuator as the normal suspension. Here we have the equation. They are the same. Not the same, but they're very similar, as we can see. But there are differences, like here, that they have more dampers. And according to the research, this type of suspension is better than the normal suspension because it's smoother. And they also said that the active suspension, it is much better than the passive suspension. So for them, it may be worth it to pay for it. Finally, I'll talk about my contribution to the research. When I did the research, I focused on commercial solutions, and that's what I did in the other one. I found the commercial solutions. And here's the bibliography. Thank you.